Hello guys, so we are going to continue the discussion with respect to derivative. In this video, we are going to go ahead and check out the mathematical notation of derivative with limits. So I'm also going to introduce limits over here in this specific topic. When I say mathematical notation, we'll talk about a generic mathematical notation. Before I go ahead and discuss more about it, first of all, let's understand the definition of derivative. A derivative is a fundamental concept in calculus that represents the rate. Now this is very important, that represents the rate at which a function is changing at any given point. And this is what we basically discussed in our previous video. It is essentially the slope of the tangent of the line to the function graph at that point. Okay. And the remaining things you can actually read. But already I have discussed in my previous video, like what exactly is a derivative and how it is different from slope. Okay. Now let me do one thing. Since we have to come up with a mathematical notation over here, how to find out a derivative, right? So first of all, what I will do is that I will take a coordinate system. Let's take a coordinate system over here. So this is my entire coordinate system. Okay. Now in this coordinate system, let's take till here. I'm going to use a line. Let's say the line function is nothing but f of x mx plus c. Here m is my slope and c is my intercept. Now what is this equation? This equation is a equation of a straight line. So I may get this straight line which looks something like this. Okay. And this is what it is basically represented by. Now if I want to go ahead and calculate the slope, right? And here I can have my x-axis. Here in the y-axis it is f of x. F of x is nothing but this function. Now let me do one thing. Like if you really want to calculate the slope, what exactly the slope? If I have a straight line, right, how do we calculate a slope? Let's say that I want to calculate the slope over here. I can take two coordinates, right? I can take this one coordinate, I can take this one coordinate. And then with respect to this two coordinate, we'll try to understand that with respect to change in x-axis, how much change is there in the y-axis, okay? And let's consider this point is specified by A, okay? So A is one of the data point in x. And this point is nothing but B, right? Let's consider this as A and B. And with respect to this A, if I go ahead and plot over here, so this will basically be my f of A, right? And similarly, if I go ahead and plot this, this is nothing but f of B, right? Now, in order to compute the slope, how do we compute the slope over here? So if I want to go ahead and compute the slope, slope is nothing but we go ahead and write it as something like rise divided by run, right? Rise divided by run basically means what is the change in the y-axis with respect to change in x-axis. I can also go ahead and write it as y2 minus y1 divided by x2 minus x1, right? Now you know what is y2. Y2, this particular point over here, y2 is nothing but f of b. So I will go ahead and write f of b minus f of a divided by b minus a, right? And this is what is the generic equation for to find out, sorry, delta y by delta x. Okay, this is the most generic equation that in most of the textbooks also you'll be able to find it out, right? So let me just go ahead and represent it. Now just by using this particular formula, you will be able to calculate the slope of this line. And as you all know, right, for this, right, let's say if you have two coordinates, you can go ahead and compute it. One thing that you should understand that over here, since the line is straight, all the slope is going to remain same with respect to any two data points. But our main aim is to go ahead and find the slope with respect to a curve, right? So over here, what is happening? Here is a straight line. I have two coordinates. I can go ahead and find out the slope. And with respect to any two data points over here, the slope will be almost same. And this basically talks about like if there is a unit movement in x, how much unit movement will be there in the y-axis. Okay. And based on that, you can get a positive slope or negative slope. But we really want to understand what will be the generic notation for a slope if you have this curve line. Let's say that you have this specific curve line, right? Let's say that there is a curve line like this, right? Now in this scenario, what do you think should be your slope? And we have already discussed over here. Let me just go ahead and define this curve once again. So it looks something like this. Let's go ahead and talk like this, right? So here also, you know that if I really want to find out the slope, let's take up two arbitrary points or two coordinates. Okay, let's say that this coordinate in the x-axis is denoted by x0. Okay, and this is my x-axis, right? And this is basically denoted by, this is nothing but it is denoted by x0 plus h. Okay, h is nothing but the length from here to here. Okay, now whenever we have this two coordinates, obviously we have also understood that we can probably go ahead and create a secant line, right? We can create a secant line, and this secant line will, if we calculate the slope, we should be able to calculate the slope, the average instantaneous. I can also say that just by calculating the slope of this line, we'll be able to get the average rate of change with respect to x and y, right? We'll be able to calculate it, right? So if I just zoom in this curve, and if I show you, let's say if the curve looks like this, if I have these two data points, so what we'll do is that we will first of all draw a secant line, right? Once we draw a secant line, so, and finally we just go ahead and compute the slope. So this will basically give the average rate of change. The secant line slope is just going to give, the average rate of change. Average rate of change, right? Average rate of change. What does average rate of change basically means? Now see, in this line, when I draw this secant line, here all the rate of change is almost similar for this straight line. But if I consider this curve over here, it is little bit less when compared to this particular straight line. Then it is increasing, then it is increasing, then it is matching the straight line, right? So here at every point, the rate of change is actually different, right? In whenever we have a curve, right? So our main aim is that we should be able to find what is the exact change or what is the exact rate of change at this specific point. So for doing this, we really need to go ahead and create a tangent, and then we will go ahead and calculate the slope, right? But right now, since we are coming up with a mathematical notation, let's first of all take this particular 2 points and let's go ahead and see this specific slope. Okay, and then we will go ahead and write this particular mathematical equation. Then if we really want to go ahead and draw a tangent and probably calculate a slope for a specific point wherein we determine that what is the rate of change at this point, we have to use something called as limits. How that limits will be used, I'll just tell you in some time. Okay, now just imagine that this was my straight line, so I have x of 0 and x of 0 plus h. Okay, now similarly for this x of 0, you should understand that what is your f of x, right? So if I'm considering this as my f of x, right, instead of y, I'll go ahead and write f of x. So what is my f of x over here? So here it is nothing but it is f of x0, and in this case, since it is x0 dot h, I will go ahead and just plot it, and this is nothing but f of x0 plus h, right? Now if I want to probably do the computation again, you know, in order to calculate the slope, how do we do that, right? So in slope, we can go ahead and write, it is nothing but, first of all, you go ahead and see what is the y2. It is nothing but, see, like this it is, right? Delta y by delta x. Delta y is nothing but y2 minus y1 divided by x2 minus x1. So what is exactly y2? Y2 is nothing but f x0 plus h minus, which is my y2 coordinate over here. It is nothing but f x0 divided by what is x2? X2 is nothing but this one, x0 plus h minus what is my x1? It is nothing but x0, right? So this is nothing but, this is my delta y by delta x, right? Delta x, right? Now if I further go ahead and calculate it, so here you'll be able to get the most generic equation that I can write. F x0 plus h is nothing but f x0 minus f x0. With this, if I expand this x0 and x0 get cancelled, and finally I actually get h over here, right? Now once I get h over here, now the next important thing is that what exactly this equation is. This equation is nothing but, it is the slope of secant line, right? Secant line. What is secant line? Let's say in a curved line, if I have two coordinates, if I draw a straight line and passing through both the coordinates, then that is exactly a secant line. in geometry, right? So we use this. So this is my entire equation, right? So if I want to calculate the slope of a secant line, this is how we specifically go ahead and write it, right? Since we have calculated the slope. But now is the most important thing. But that is not my aim. I don't want to calculate just the secant slope of a secant line. I need to calculate what will be the rate of change at this specific point, right? Then how do I probably go ahead with, now just try to understand this. I have to convert the secant line to this tangent line. And how it is possible? We have to move from x0 plus h towards x0. Now, when we are moving towards this, what will happen? When your x0 plus h will reduce. So my second point may come over here. My third point may come over here. Now see, for every point, if I just go ahead and draw this secant line, right, you'll be able to see as soon as I reach towards this particular point, finally I'll be able to get this, right? Now the main thing is that I have to make this x0 plus h to move towards x0, right? Move towards x0. That basically means this h value should move towards 0, right? If I do the difference of x0 plus h plus minus x0, it is nothing but h, right? So h has some value. If I want to make this as is equal to 0, I have to move towards this point. And then when I'm moving towards this particular point, right, and then I have to probably come up with this single point. See, at the end of the day, when this s0 becomes 0 over here at this particular point, this is nothing but we are basically calculating the tangent at this particular point. Now, how do we move with respect to this? Now, if we really want to move it, we will be using a limit, right? So here is why you specifically use a limit. We'll say, hey, limit h of 0, where we are going to use the same equation to calculate the slope, which is nothing but f x0 plus h minus f x0 divided by h. And this is what limit talks about. In limit, what we are doing is that we are telling, hey, your h should be becoming 0. That basically means we really need to move at this point. And that is how your secant line is going to get converted into a tangent line. This is the most important thing, right? And this is how you can specify your default notation, right? And this entire formula can also be represented as f dash of x. F dash of x is nothing but it is something called as the derivative of f of x. Right? Derivative of f of x. This is how the notation is specifically written as, right? One way of writing this is also dy by dx, right? Where y is nothing but your f of x. So here you can also write this as derivative of f of x divided by d of x. And this also we'll get to know later on. We will talk about this equation later on. But right now, just make sure that you understand how we came up with this kind of generic notation along with limits. Why specifically limits we are using over here? Limit basically says that, hey, if we want to really move towards this and try to find out a rate of change at a specific point, the secant line needs to be converted into a tangent line. So this limit is specifically doing that, wherein the h is moving towards 0. H is moving towards 0 basically means this point is moving towards this, and that is how your entire secant line will get converted into a tangent line. Once it's get converted into a tangent line, you can also go ahead and calculate the slope, right? And I hope you are able to understand this entire thing, right? So yes, this was it. I hope everybody understood about this generic notation and how do we notate this right over here. So this was it from my side. I hope you like this particular video. There are more things that are going to come up in the next video where we are going to learn many things about derivatives as such. Yeah, this was it from my side. I'll see you in the next video. Thank you.